Hello, good morning, and welcome to our Predictive and Prescriptive Program Deployment Planning for Facilities Intelligence online learning series, July 20th, 2022. My name is Bill Thompson, and I'll be the facilitator today. Our session will be led by Jed Theobald, Senior Reliability Engineer here at Data Mirror Solutions. Jed, can you go to the next slide, please? Before I turn it over to Jed, I'd like to bring up a few housekeeping items. Number one, this session is being recorded. A recording link will be sent to all registrants. This is a live event. Participation is encouraged. We have received some questions during the registration phase that we will ask Jed at the conclusion, but we encourage additional participation as we go through the different components of our presentation today. There's a questions panel within your GoToWebinar application, and you submit those there, we'll take care of it. So with that said, I'd like to hand the reins over to Jed Theobald. Jed, the floor is yours. Thank you.
Thank you, Bill, and good morning, everyone. I appreciate you joining us today. Beautiful morning here. As Bill discussed, we're going to be going over our predictive and prescriptive program deployment with our focus on planning for facilities intelligence. So in planning for facilities intelligence, that intelligence is a data-driven effort. And with that data-driven effort, there's a fair amount of upfront planning, some housekeeping, and really some program development that we need to be focused on. And then we can get back to these different data streams of how they tie into those work streams, and then how we're gonna get that data in a singular location, how we can analyze that data, and then really how we're gonna correlate and then make good, solid, sound business decisions from that data. And so without any further, I'm gonna go ahead and move on to really the framework, and what we've developed here is from a risk-based asset performance management deployment model. So with this, we're going to work from left to right with our strategy. I want to just emphasize here the intent of this webinar is to focus on this reliability work stream, but that's not to take away from these other work streams such as the leadership, maintenance management, and of course materials management, and how this all ties together with your facilities and the overall strategy that your organization is going to be approaching with. So with that, is what we like to start with is really we want to go into this current state analysis and really get to understanding of where your facility currently is in your organization. And it kind of comes down and breaks into these three buckets. So the initial is the data collection. Then we're going to take all that data, analyze it, correlate it, give it a quantitative, value, and then we're going to develop our strategy and deployment model and tailor it to what your organizational needs are. So is really the first step in that with the data collection is we need to understand what your business objectives are. So really within your organization, your senior leadership is being driven and is being judged based on their business objectives and their ability to achieve those business objectives. So if your senior leadership is driving a direction, really all the way down within your facilities department, all the way down to the technician level, and even contractors, we all need to be, in line with those objectives, and we need to be marching in the same direction. So from our standpoint, we need to know what those are, and we need to know where your organization is in keeping in line with those business objectives. So to do that, we fundamentally get your business objectives, move on to the comprehensive evaluation of your site through really it's going to be a combination of things. We need reports, so we can get reports beforehand. We can have video conference interviews, but the bulk of it and really the meat of a current state assessment comes from that on-site evaluation and getting personnel interviews face to face, so you can have a good understanding and a good read on these individuals and a better understanding of what's really going on. So those focus areas, as you can see, are going to be the maintenance, reliability, and operations. Right? Those are the three major streams that we want to focus on, but that's not to say that we don't need to take it. We need to take a look at your MRO. We need to know if you have the space. Do you have too many parts? Do you not have enough parts? Do you have organization set up? Is your leadership supporting your site and what's going on? And then driving into your safety, that's always an aspect that we have to be focused on. But the culture of your organization is something, it's hard to get a read on that initially, but our on-site, current state assessment is where we can get a good feel for that culture and see if there's something that we then can, implement within our strategy development and our deployment model. So with all that information we're going to gather, we want to then come back to our data analysis, component, and we need to put it, in a readable format. We want to assign a quantitative scorecard and a score to it. And really when we want to compare it against industry standards and averages. So we're going to benchmark it, and then we're going to see where it falls in line with industry best practices. And the goal with that is we want to understand, obviously, your strengths, because not everyone's going to be completely broken. That's not the intent here. But we want to see, obviously, where your weaknesses are, whether or not you want to know what they are or not. I would assume you do want to know what your weaknesses are, because that's what we're here to improve upon. And then we want to really kind of get that in a report format so that we can move forward with our strategy and deployment model. So once again, we're going to develop the strategy and deployment model, and the output of this is going to be kind of see where you fall on this spectrum. So the reality is we want to be operating in the blue and the green over here, where we're in a proactive and an optimal, reliability plant. We're driving towards the failure elimination and optimized, where the reality is most likely we are in this failure management area, where we at least want to know where we're at. Are we all the way on the left in the red? Are we just reactive? Are we putting out fires day in and day out? Or are we actually shifting towards, maybe your facility's in a predictive state, but you want to get to the next level. So the reality is it might not be simple enough that we come in, implement a plan, and you jump from red to blue, when really we want to make, some smaller adjustments, get to the predictive state. We're still in failure management. And then through the data collection and through analyzing this data, we can then shift into this failure elimination mode and move on from there. So with that, as you can see with our model, we want to focus on our business objectives on the left, because they're what's driving this whole effort. So we want to understand those business objectives, and we want to see where they tie in with our people and process, our systems, our technology, and then of course our governance. And we want to compare that to your current KPIs to see if you're monitoring, what you're monitoring is actually in line with your business objectives and your processes. And then from there, we'll see where you fall out. And at the end of the day, the goal here is to be on the right side, where we're focused on the data-driven strategies, and we're not just, maintaining status quo, and we're using the information and from the facilities intelligence side of it to drive the strategy and to get past this, the current state of your facility. So with that, that's just that's where our current state assessment, analysis is driven and where we want to go with it. But in order to continue, down this path of reliability, we need to understand obviously where your facility's at, but we also need to understand your assets and your master asset lists. And in doing that, we have found that a lot of master assets lists tend to be incomplete. Now, the goal for some organizations will be to maintain it in a CMS system, but the reality is the upkeep of that, they have not kept up with. Maybe the processes are broken for their asset introduction. So this incomplete list is going to ultimately affect down the road as we're trying to deploy technologies and deploy a process if we don't understand all of our assets on site. So in doing that, we want to take a deep dive into this master asset list. We want to verify, what you think you have on site, and then we need to tie that in kind of with the current state assessment and actually get an accurate list And with that list, there's some information that we want to use and utilize while we're doing this to then go ahead and build and get ready. And it's kind of this upfront preparatory work that we're going to need down the road. So we want to obviously get the asset type, the subtype, basic information, manufacturer, model number, serial number. There might be some additional key specifications. Maybe you have good images of all the stuff, or we need to make sure that we get into the actual OEMs and get some of this additional information here, which is going to kind of build a more robust master asset list. And once again, this is to help facilitate, this preventative maintenance, predictive maintenance program, and then drive, what we're trying to get out of here, and that's to shift from a reactive to a proactive facility. So, like I said, these are just some examples of the information we want to gather. And once again, this master asset list is going to be the foundation of the next few steps in our process. So with that, once we have the master asset list and we're confident that it's accurate, we're gonna drive into determining which assets on site are your most critical and which ones are your least critical. Because the reality is we don't want to. Not every asset's the same, and not every asset should be treated the same. And so we don't want to invest time and money into assets that just frankly aren't of value. So with that, depending on the tools, depending on your criteria, the main focus, some foundational criteria for an asset criticality will be safety, maintenance, production, and then regulatory concerns and attention that can be associated with that asset. And when you get to the usage of the asset criticality, it's going to determine our operational and maintenance strategy, our prioritization of work orders depending on the criticality, and then really it's going to drive the next part of our program, which is the risk management and the associated program areas, and really kind of also the technologies that you want to then deploy on these assets. So with that, it's asset criticality. And now keep in mind that these scores are fully customizable, and frankly, even these strategies on the left here between the reliability, maintenance, and continuous improvement are all customizable depending on your organizational goals and frankly, your budgets. So for instance, with the budgets, FMEA is a very labor intensive and time consuming engineering analysis that can be applied on an asset, on a very specific asset and subcomponents, or it can be on a asset class. And with that asset class mentality and thought process would be more along the lines of this streamlined FMEA. And then, going down the scale here, you can see it's not always cost driven, but it kind of ties into that mentality of your expenses and eventually, ultimately, your return on investment. So with that, like I said, these are fully customizable. If we want to apply FMEA at all, it's there. But really getting down in this maintenance activity level, we don't want to be doing condition-based maintenance and condition monitoring on all assets, because if it's either an automated or manual approach, say for vibration, there is time, there's labor, and there's technology associated with that all cost money. And if you're concerned about downtime, and that downtime is money, then that's a different approach. So a lower valued asset might be more applicable. But really, we want to make sure that we're applying these activity levels to the right criticality score, and that criticality score is going to be, driven from once again your organizational goals and where you guys are headed. So with that, once we have our asset criticality score, and we have, once again, the strategy development, we're gonna shift into, like I said, the meat of this webinar is focused on our reliability work stream. And the first step in our reliability work stream is diving off into our proactive maintenance strategy. And as I discussed a second ago, not every asset's the same. And so if we're going to invest in our most critical assets and then essentially de-invest in our least critical assets, we need to figure out which one of these maintenance strategies is most applicable to that asset. So if it's a least critical asset, if it's low cost, it's most likely going to be associated with a run to failure. Now that being said, not everything's a run to failure. We're not saying that that's the best approach, but the reality is there's a lot of equipment and facilities that it's not worth the time and effort to worry about it or throw even that maintenance resource at it, and that time, that valuable time that we're all having issues with our maintenance technicians. Let's go ahead and let that asset run to failure. So then as we move up with our strategies here, we get into, all right, maybe the next level, we want to just take a look at our current PMs, take a look at those job plans, and then really just kind of standardize where they're at. We don't want to make significant modifications to them because that's going to require some significant effort. And then also, maybe you frankly have assets that just don't have PMs written against them, and they should. So that's where we're going to kind of, between levels 1 and 2 here, we're going to develop that with using OEMs and kind of known failures that we've tracked through some of our data analytics. So the next approach would be getting into our the PM optimization, and that's going to be looking at a more detailed task list, making sure that those tasks are appropriate, which we'll talk about this a little more, and then maybe some of those task lists need to be adjusted and shifted to a predictive thought process, and then applying predictive technologies to that. And then lastly, as I talked about earlier, the FMEA, and we'll talk about this in a second as well, but this is, we're at what level we want to apply this. It is the most labor and time intensive and most costly, but also there are going to be assets where it is deemed applicable, and we'll address those as necessary. So with that, for FMEA, simply put here, there's some fundamental steps here. The FMEA is a detailed engineering analysis. The goal is to drive out and determine failure modes, how we detect those failure modes, and then assign tasks to each of those failure modes, either on a time base or a predictive approach. And we want to get towards this on step 6 there, these proactive tasks to, like I said, prevent those failures. Now, the reality is every industry has a different tolerance for failures. So the FMEA was derived from the airline industry and their lack of tolerance for failures. So since the airline industry can't have any in-service failures, they're going to have a very detailed FMEA process. And we're not saying that that's going to be applicable to all facilities because it's just the nature of it's not. But really, that's where we kind of get into that, like I said, that streamlined FMEA process where we can do it to an asset class. We can do simple systems such as a centrifugal pump or maybe an air handler, and we can address the major failure modes associated with those. And then once again, make sure that our tasks that we have within our PMs, either we're monitoring for these conditions to generate corrective work orders, or we have time-based PMs that will address these conditions and make sure that we're preventing them. So like I said, the FMEA, it is the gold standard as far as the engineering analysis and determining failures, but it's also the most labor intensive and costly. And so we want to only apply this on the most critical assets in your facility if we're going to apply it at all. So with that, going to the next level, our PM program development and optimization. It's derived once again from that master asset list, the criticality. You have to know your equipment in order to know if you even have to have PMs assigned to it. So, unfortunately, in some industries, you can find equipment and then you'll find no PMs written against it, and they can't figure out why they have to keep replacing this equipment, and then they don't understand why there's no PMs written against it. Well, that has to do with your like I said, your upfront, your asset inspection process and your master asset list management. But what we want to do here is we want to focus on making sure that the right assets have PMs written against them. And then with those PMs, we want to make sure when we dive off into the PM optimization that we're making the correct recommendation based on the criticality, the failure modes, the frequency, and the impact of those failure modes, the maintenance practices associated and linked to those failure modes. And then we're going to make a recommendation of really what we want to do with that PM. So some simple options, like maybe it's fine as is, so no change to that task. Maybe delete, change a task, add a PDM task to deal with a failure mode that's not currently addressed, and that would be something that we could drive either from the historical data or an FMEA. Change of frequency, so the goal is to have the correct PM to CM ratio, and overall the goal is to have all of our corrective work orders driven from PMs and PDM, and not have CMs that come from in-service failures that we were unable to detect or that we just didn't determine could happen. So, and lastly, I want to we can adjust the responsibility of a task, and this is industry specific, to shift instead of from technicians and maintenance technicians to operator care. So with that, a simple example of a PM optimization would be I have a PM that's written to go out and inspect the light bulbs on a control panel and verify that all the lights are lit, all the lights are lit. So if all the lights are lit, that's great, signs off on it, and that technician then walks away, and one light bulb burns out. Well, if that's a monthly PM, that technician is probably not going to go back to that panel and determine, and for a month that light bulb was out. When in reality, it was operators routinely who look at that panel that would see that lights burned out. They might write work order, might not. They might just have a bag of light bulbs, take that light bulb out, replace it, verify it works, and then move on with their day. So why would we're going to challenge that PM, and we're going to ask, why am I performing that task if it really adds no value, right? It doesn't address a failure mode, and it clearly doesn't affect the operation of that system. So, like I said, that's the kind of the foundation of our PM program development and optimization, and why we want to incorporate that within our strategy. Once again, the bulk was getting this predictive approach is going to be driven from what everyone's more familiar with, which are our predictive technologies in our PDM program development. So with this, there's a couple strategies. There's more of a traditional, which I'll discuss here in a second, a traditional PDM approach. But we wanted to take a step back and try to create a more robust, detailed, predictive approach, and really make sure that we're getting past this detection and this failure management, and get to a failure elimination thought process and/or strategy. So some of the basic technologies, so we're on the same page. You have the vibration is most common, ultrasound, infrared, oil analysis, and then motor analysis. And those will be, driving really all of our technologies, get into our data collection, analysis, and then repair and verify. And with a traditional program, you'll design the program around those technologies. You'll determine the technology, do some training. You might include certain vendors to do either, because maybe there's a certain vendor that is a best fit for your facility, and here at Data Mirror, we're a technology agnostic organization. So that depending on which technology is the best fit, we will make that determination. And then really, this gets into the data collection. You analyze it and then repair and verify. And that's kind of a rinse and repeat process. You'll continue down this path. The problem is this is a failure management approach. So instead of waiting for that equipment to fail, you're determining that failure in its early stages. You are planning the downtime, so you are doing some cost avoidance there. And then at the end of the day, you're still dealing with the same failure, but you're not getting rid of that failure. And that's what we're trying to get away from. So with that, we've developed what we're calling an enhanced PDM program, where we're going to go for a more balanced program design. So we're going to apply the right technology for the right equipment, and we're going to make sure that we're not just applying all technologies to all equipment, right? So that's the goal there. And then we're going to use the PDM program best practices. We're not trying to reinvent the PDM, industry. And so we're going to use what's available. We're going to potentially use data analytics that are available, and then we're going to go into this, this data collection cycle. We're going to perform the analysis, and we're going to generate work orders, and we're going to repair and verify. So with that, you're going to start getting this data, which we're going to use to then drive out these failures and really get into the enhanced portion of our program, where we want to dive off into the next page, the centralized cloud data and the recognizing the data patterns, benchmarking against industry standards, and then once again with that data analytics, we're able to actually make a determination if this is a recurring failure, if this is a recurring failure in the industry, maybe within just your organization or in your facility. And then really we're going to dive off into the root cause failure analysis piece to really drive home that, hey, all right, we have great technology to find these problems, but we're not actually preventing the problems. And that's where we want to shift towards. So with that, for the root cause failure analysis, so just this quick survey, and is what I think is more applicable now than ever, is we're seeing human errors are the bulk of issues. It's not, manufacturing tolerances are getting better, equipment's getting better, lubricants are getting better, the technology is getting better, but we're seeing a shift with the human error and the personnel problems. So for instance, this pie chart shows the bulk of it is all human error driven. So by performing a root cause failure analysis on that problem, the next slide, for instance, here we have the bulk of the issues you can see on the left are all vibration detected, but it's like, why am I having consistent rolling element failures that are dwarfing the rest of my issues? And with that, like I said, the far left, the 6 columns, those are the bulk, if not 95% of the issues, which can be derived from the next few areas, which are, once again, human errors. And those human errors come from a couple different areas. The number one human error is really just not having the right training or tools to perform this precision maintenance aspect of it. And throughout is there is a plethora of tools out there to help your technicians be more precise with their maintenance. And the reality is they sometimes just don't get the tools. And then even if they get the tools, they got to be trained on those tools. So, we want to make sure that we have that aspect as a part of our enhanced PDM program. And as we do this, you'll start seeing those problems be driven out. Now that misalignment should be less and less. So make those rolling element failures. And as the data collection happens over time, it's going to take a while. So initially you can have say 6 months to a year, get this program developed, deployed, and be collecting data, but you're going to need 12 months to 18 months of data collection to be able to drive out these root issues and these root causes. And then we can shift into this performing the precision maintenance, get into our dashboard, which will drive our KPIs and metrics and be able to display these. And really ultimately it comes down to, you can't manage what you don't measure. So if it's worth measuring, then we want to make sure that we are analyzing it and we're taking action on it. And that's kind of the next step, getting into our continuous improvement. And once again, on that initial slide with the spectrum, you want to understand within your different areas and your different results where, from our current data assessment, we will see where your different programs are and where we want to trend towards the blue and the green, right? We want to get on that predictive side and that proactive side of our strategy. So I just want to touch on the precision maintenance piece one last time. But without that precision maintenance, really, you're never going to actually drive out a lot of these problems. So there are significant, installation errors, as you saw on the one pie chart. There's misalignment issues. There's over and under lubrication issues. And really, it's that training and the tools. So making sure that whichever industry you're in, you have the correct tools for your industry. And then, once again, training, right? You have to have timely training, and you have to reinforce that training, and you have to make sure that the individuals understand the importance of that training, and then they will see on the back end the benefits of it. So if they're no longer putting out fires all day long, they can focus on, understanding really how that maintenance is, affecting them, and then they will see the benefit. And once you get that benefit, that's where you start getting into our cultural transformation, and you really start getting the buy-in from that level up. So with that, like I said, I wanted to, the focus here was on our reliability work stream. It's not to take away from our maintenance management or our materials management or even our leadership work stream, which all ties in to our overall strategy. But just to real quick touch on the maintenance management, the reality is, like I said, there's a lot of human error, there's a lot of training, and frankly, there's a lot of issues with just planning and scheduling within organizations that you need to address, you need to understand the current state of. That way, when you move forward, not only do the guys have the right tools, they have the right manning, they have the right training, and they're not being overburdened with incorrect planning and scheduling, correct? The last part, the materials management work stream. So with that, the MRO optimization piece, like I said, we'll have a good current state assessment of your facility. And really, it kind of comes from the whole process, but also that FMEA for critical assets. We can make critical spare determinations. We can do inventory assessments, figure out, like, you might have a bulk of your parts, or maybe they're outdated, or they are just obsolete material. And really having that material on site can directly affect not only your MRO operations, but if your MRO operations are slowed down with the supply chain being slow, guys not knowing which parts are the correct parts, it's going to affect the whole organization. And so it's not to say it's less important, but that, once again, is not the focus of this webinar. And really, the kind of tie it all together, I've touched on a few times, is getting into the KPIs and metrics development, right? Because if we're going to measure it, then we can manage it. So with the KPIs, we're not, once again, not to reinvent the wheel. We fall into these three major categories, and we have economic, technical, and organizational indicators, which can be broken down into our leading and lagging KPIs. And then, once again, aligning our KPIs to your business objectives, and really kind of fall into, what we're doing here. Are we measuring the status of the organization, the process, assets, or we doing internal and or external comparisons with the KPIs? Once again, strengths and weaknesses. I know people don't like being told where their weaknesses are on an individual level, but in an organization, you got to know what your weaknesses are to know where these areas of improvements are, so we can actually align with those business objectives. Going down, once again, identify objectives, define operating targets. We want to plan for improvement actions, right? We want to eliminate those weaknesses where we can, and then ultimately get down to our budgeting and strategy planning for, the leadership component of our KPIs. So here at Data Mira, with all that and focused on the data side of our process and our planning, and like I said, that whole roadmap is the upfront planning and preparatory work is to really get that data out to drive those KPIs, and really that data we want to put in this data lake concept. So you can see some of these programs, these different technologies, these systems it's not getting these systems to communicate together, but that we can get the correct data from those systems, put them in a data lake. We can then have a dashboard that will then, take a look. You can visualize, you can correlate, and as you can see at the bottom there, we're going to acquire, standardize, integrate, and correlate that data. When you get into the next column here, when the organize the data, we want to analyze it and visualize. Then we can start driving our advanced analytics, get into the prediction side, which ties into our predictive technologies, the machine learning, and then maybe someday we can dive off in artificial intelligence when that day comes. But the reality is all this data and getting it all in one location is important, but we also want to make sure that we have good quality data coming in so we can make good education decisions on the back end. And with that, I'll turn this back over to Bill.
All right, Jed, thank you so much. Very thorough explanation. Appreciate it. I would like to reiterate Jed's request. If you have any questions you'd like to submit, you can do that on the questions tab within the go-to webinar panel. We have some questions now, Jed. I'll take a breath and start with the first one received. How do you know what to monitor? I don't have any context there, but how do you know what to monitor?
Yeah, so how do we know what to monitor? So that's going to come down to really we want to right size our technology to the assets, and knowing what to monitor is going to be driven from not only your business objectives, but also from that master asset list and the asset criticality. So once we have, like I said, a detailed master asset list, we can derive the asset criticality. We determine if that we want to invest in that, and that's how we're going to make that determination. And ultimately, when we make that determination of what we want to monitor and what we're really what we're looking at, it's going to go down once it's driving that return on investment. So we want to right size the technology to maximize that return on investment, and then it's going to ultimately make the determination from a maintenance standpoint of, is it worth investing in repairing that asset, or is that an asset that we just want to replace? So for instance, maybe for an assembly line, you have a gearbox that's driving the assembly line that's only $500 to replace. So in the event that gearbox fails, I'm going to in determining it and throwing technology that monitoring it monthly is going to cost money, and then really even making the repairs to that asset is going to cost money. So say it's a 5-hour job to repair and it's a 2-hour job to replace. Well, that's going to tie into right sizing it, and that's going to make that repair versus replace determination, and ultimately going to drive which assets that we want to monitor.
Great, thank you, Jed. Okay, second question received. How do you differentiate managing both newer and older facilities?
So, good question. So there's not the difference between an older and a newer facility isn't significant, with the exception of with an older facility, with like when you turn on a machine and you run it for the first time, there's going to be a certain amount of infant mortality. And with an older facility, you're going to have that infant mortality is going to be less because you're past that stage. But you're going to be potentially past the bathtub, which is the lower portion, and you're going to actually be rising on the end of life failures that you would expect from those assets. So you will be in an older facility, you're going to be focused on that end of life failure. a newer facility, you'll be focused on the beginning of life failures, those infant mortalities, and also just is going to have a higher likelihood. And really, it's going to adjust your risk and probability when your analysis, especially towards the end of life. So overall, there's no one size fits all with our program, and the goal is to figure out what data you do have from your facility, what data you want to get from your facility, and then the technologies that either in a new facility are going to have more information available than an old one. So we might have to actually install more technology in an old facility. But like I said, it's no one size fits all, and it's going to ultimately come down to a customized solution to the newer old facility you're operating with.
Thank you, Jed. Yeah, we took a polling question before the session, and there was a number of people who had the same newer managing both, and wanted to make sure that we covered that in the Q&A. Great. Okay, we have one more question at this point. Have you seen a shift from a traditional to data-driven approach on predictive strategy?
So we have seen a shift towards the data-driven strategy, and that's really the IIoT approach, and really that cloud-based organization, and being able to actually, from facility to facility, even within organizations, that communication flow back and forth has really shifted the mentality and actually gotten to where, if I'm assessing failure modes within one organization and one site, I can now compare that to another site and the data that they've collected, and ultimately come up with how they have resolved those problems. And then it also has tied into, some of the wireless technologies that we can also deploy within our facilities, which the wireless technologies are excellent depending on the situation. Maybe some harsh environments that you can't, access, send an individual in for instance, manual data collection, or even really just in general, the production line doesn't want extra human contact with it. So by really, like I said, the IoT driving the online and the cloud-based information sharing, and then this ability to deploy wireless technologies is really has improved those processes.
Great answer. It's hearing about the communication lines opening, both technology and within the different groups is the ultimate goal. So it looks like we'll give another 30 seconds or so if there's any remaining questions or any follow-up to the ones we received and responded with. Jed, you can go to the next slide, please. Let's give it a few more seconds. Okay, it looks like we're about a quarter away from 11 o'clock. We had a 45-minute goal this morning, and looks like we're pretty close. If there's nothing else, I would like to, on behalf of Jed Theobald, I'd like to thank everyone for attending this morning. I'd like to invite you all to continue to keep track on our progress as we grow within some of the programs we've developed and our industry communications on some of the best practices we've deployed. You can visit our website at datamira.com. You can visit our company profile on LinkedIn. You can always reach out to info@datamira direct if you have any follow-up questions on this topic with Jed or anyone else at Datamira Solutions. We'd be happy to help. On behalf of Jed Theobald, this is Bill Thompson. I'd like to thank you again for attending, and we'll see you next time. Bye-bye.